So let's start with the first question. As I share on my screen, I will let you vote on Kahoot. We are interested in the expression that describe exactly one of the three events A, B, or C occurs, and you should try to interpret the meaning of each expression here. And then this union means that or, so either this happen or this one or this one. So it is true or false that it describes exactly one of the three events happen. For people who didn't join Kahoot, you can just drop your answer in the chat. Actually, I'm not sure how to end the voting early on Kahoot. Let me see. Okay, so we have 5 votes for true, and that is the correct answer. Can someone okay, I see someone say false. Do you mind explain why? Why do you think it is false? Yes. I just dropped the passcode to Kahoot. Let me know if you can join it. Can someone explain why it is true? The first question, you can either type in the chat or you can unmute yourself and speak. There are at least 5 people who chose true here. So how do you know that it is true? What does the first expression represent? I think it is true because each term isolates A or B or C. Yes, kinda. So the first term, it is saying that we want A and not B and not C, right? Because B prime mean that B complement and it indicate not B, and C prime indicate not C. When we have A and not B and not C, it means that only A. Similarly, the second term mean that only B, and the last term mean that only C. And the concatenation, sorry, not concatenation, is a union. It means the word or. So we have only A or only B or only C, and it describes that exactly one of the three events A, B, or C occurs. Therefore, it is true. Does it make sense? If it makes sense, you can maybe just give some reaction. Okay, thank you, thank you. Let's move on to the second question. This is the second one. If it is true, you should be able to explain why. And if it is false, you should be able to come up with a counter example. Please think about it and vote on Kahoot. If you didn't join Kahoot, you can type in the chat. One more minute. Let me know if you have any questions. Okay, so we have 6 people choose false, 2 people choose true, and there's people who say, I don't know, that is fine. So let's look at this. Why do you think that it is false? For whoever that voted false, how do you know that it is false? Let's break this down. This one say that the probability of A exclude B is at most 1 over 3, and A exclude B is this part. Okay, I see some student answer. If A and B does not overlap, it could be false. Yes, that is correct. So if we look at this one, the part A exclude B, it is this part here. And what the question is saying is probability of A, which is this circle, minus probability, which is this circle, is 1 over 3. Then this part will be at most 1 over 3. That's what the question is saying. However, we can show that this is false. You can just pick the part A exclude B to be 1 over 2. And then we will try to make probability of A minus probability of B equal to 1 over 3. How do I do that? Let's say I want here to be 1 over 3. Then probability of A would be 1 over 2 plus 1 over 3, which is 5 over 6. And I want probability of B to be probability of A minus 1 over 3 because I want this part to be true. I want that probability of A minus probability of B equal to 1 over 3, but I want this to be false. To show that the statement is false, I will have to choose some example such that the if part is true and the then part is false. So here I have 5 over 6. minus 1 over 3, which is 5 over 6, minus 2 over 3, which is, let's see. So I have 3 over 6, which is 1 over 2, which means the part here plus this one has to add up to 1 over 2. So I have the part B exclude A would be probability of B 1 over 2 minus the intersection between A and B, which is 1 over 3, and this would give me 1 over 6. So this Venn diagram is the counter example that the statement here is false because I have probability of A minus probability of B equal to 1 over 3. However, I have probability of the part A exclude B, which is this part, greater than 1 over 3. Does this make sense? And this is not the only counterexample that you can come up with. You might have different counterexamples. That is fine, as long as you show probability of A minus probability of B equal to 1 over 3, and probability of the part A exclude B is greater than 1 over 3. As long as your example have those two conditions, then it will be a valid counterexample for this one. So the correct answer here is false. Any question? If it makes sense, can you give me some reaction? Like you can add emoji or something. Okay, thank you. If it doesn't make sense, please feel free to type in the chat. You can either type in like for everyone, or you can just send message to me if you don't want other students to see it. Let's move on to the next question. Question 3. Please vote on Kahoot if you join it. And if not, you can type your answer in the chat. For this one, you will need to recall what is the formula for binomial theorem. I see someone say it is false. Do you mind give an explanation as well? Like you can type in the chat. Either you choose true or false, you should be able to explain like why do you choose it. Since using 6 choose n will never result in 15. That's partially true. The thing is, you have to figure out what is the correct coefficient, because he might give you some other expression that for sure like 6 choose n will not be able to give you 15. However, if you multiply it with something, then it might be able to give you 15. So make sure to account for that something as well. I'm not sure, but I got 12, 15 as actual coefficient. I didn't calculate the actual coefficient, but I think it is a large number. So I have some students say 6 choose 2 equal to 15. Maybe? I'm not good at calculation, guys. Okay, let's see. So I have 6 people choose false and 2 people choose true. Let's think about this. What is the coefficient when you expand this one? So the coefficient when x equal to 2, it will be 6 choose 2 multiply with x to the power of 2 and 3 to the power of 6 minus 2, right? When you expand this x plus 3 to the power of 6 and you want the exponent of x equal to 2, then it has to be this expression, which means the coefficient is 6 choose 2 multiply with 3 to the power of 4 and multiply with x squared. So the first part, this one here, we call it the coefficient of x squared. This one is called the coefficient. And then you see that 6 choose 2 is 6 factorial divided by 2 factorial times 4 factorial multiply with 3 to the power of 4. And you are left with 6 times 5 over 2 multiply with 3 to the power of 4. And this number is obviously greater than 15, right? Because 15 is 3 times 5. And this one is 15 already. And you have 3 multiplied with 3 to the power of 4 as well. I didn't calculate the actual number, but if your expression is something like this, then you got the correct coefficient. Does this make sense for everyone? Let's give some reaction.
Yeah, makes sense.
Thank you. Okay, if it makes sense, I will move on to the next question. So question 4. If you join Kahoot, please vote on there. Otherwise, you can drop your answer in the chat. Independence does not imply mutually exclusive, so it is false. That's correct. Okay. So again, I have 5 people choose false and 2 people choose true. Let's recall the definition for mutually exclusive and independent. You say that A and B are mutually exclusive if they don't have any element in common. So the intersection of A and B is an empty set. So an example for mutually exclusive event is that you pass STA107 and you fail STA107. Those two events cannot happen together, right? Either you pass or you fail. You cannot be pass and fail at the same time. So that is mutually exclusive. And for independence, we say A and B are independent event. When you have probability of A intersect B is equal to probability of A multiplied with probability of B. So that is mathematically for definition for independent events. But if you think about it, we say A and B are independent. It means whether you know that B happened or not does not affect the chance that A happened. So you can think of it that way. Knowing some information about B, then the probability that A occurs stay the same as when you do not know any information about B. And it is also the same as probability that A happen when you know B does not happen. So if A and B are independent, then these two equality hold true. Does this make sense at this point? Okay, so just keep in mind the definition. A and B are mutually exclusive, mean that if A happen, then B cannot happen. And if B happen, then A cannot happen. But independent mean that you know some information about B and it does not give you any information about A. And also if you know some information about A, it does not tell you anything about B. So how does those two concepts related to each other? If you know that two events are mutually exclusive, if two events A and B, if A and B are mutually exclusive, it means that when you know A happened, you know that B cannot happen, right? So knowing some information about A actually tell you some information about B. So if A and B are mutually exclusive, then they are not independent. And if A and B are independent, then they cannot be mutually exclusive. In order for A and B to be independent, they need some overlapping for sure. So here we have that the events A and B are independent, then they are mutually exclusive. That is false. Because if they are independent, they cannot be mutually exclusive. Any question here? If it makes sense, can you like give some emoji again? Just to make sure everyone still follow.
It makes sense.
Thank you. If no question, I will let you attempt question 5. Again, please vote on Kahoot if you join. Otherwise, you can type in the chat. You can either draw a Venn diagram to see that if the expression makes sense, or you can actually expand it mathematically. If you draw a Venn diagram, try to figure out which part represent probability of A1 union A2 given B, and which part correspond to this and which part correspond to this, and see if you add up whether they are equal or not. I see someone put in the chat that this is true. Can you explain why? Can we use Venn diagram on the exam as an explanation? If the question does not put any restriction, then you can do it. Because this course, part of it is to make you familiar with Venn diagram. Like at least you attempt to use Venn diagram when you see some expression related to set and you are not sure if it is correct or not. The first thing I would do is just draw a Venn diagram. Because like if I cannot see any problem from Venn diagram, then I will proceed with actually proving it mathematically. But for this course, you can use Venn diagram. Okay, so the left-hand side here, we want probability. Actually, I miss one circle. I miss A2. So this circle represents A1. This circle represents B, and this circle represents A2. And we have A1 and A2 are two disjoint events. That's why between A1 and A2, there is no overlapping between them. So first, we are interested in probability of A1 union A2 given B. So given B means that we restrict to this circle only. We are not interested in anything outside the circle B. So if you look at here, where is A1 union A2? Is this part and this part, right? And also, if we look at this expression, probability of A1 given B. So given B means we only care about this circle. Where is A1? A1 is this part. And this one is A2 given B. Where is A2? It is this part. So if you take probability of A1 given B plus probability of A2 given B, it looks like the region of probability of A1 union A2 given B, right? Does this make sense till this point? Can you show how to prove this without Venn diagram? Yes. So let's we start with the left-hand side. We will expand the left-hand side. So this is conditional probability, right? I just use formula for conditional probability. I have probability of A given B equal to probability of the intersection divided by probability of B. Here, this whole chunk represents A and B is still B. So I have probability of A1 union A2 and B divided by probability of B. Do we need to prove something in the final? I cannot tell you that. But this one is the question from last year final. Most of the question that I got here is last year final exam, and then I created some more question in the same style as that. But even if we ask you to prove this one, it is reasonable because it is just applying formulas. And from here, we can use the distributivity. When you have A1 union A2 intersect B, I can break it down into A1 intersect B union with A2 union with A2 intersect B divided by probability of B. Yes, I will post this one after. Does this step make sense? Like from here to here?
Yeah, you're basically just using commutativity.
Yes. And here, what we are having is probability of some set union with another set. before we have the formula, probability of A union B is probability of A plus probability of B minus probability of the intersection of two sets, right? And here we treat the first group as A and we treat the second group as B, and I apply the formula. So I have probability of A1 intersect B plus probability of A2 intersect B minus probability of the first set intersect with the second set. From this step to this, does it make sense for everyone? Okay. And what we realize is A1 and A2 are disjoint, right? Since A1 and A2 are disjoint, so the third expression here is equal to 0. Because we have A1 intersects with A2 and it is just an empty set because they are disjoint, and probability of an empty set is 0. And we are just left with probability of A1 intersect B divided by probability of B plus probability of A2 intersect B divided by probability of B. Since this is 0, I only have these two terms left. So I have this over the denominator plus this one over denominator. And the first expression is exactly probability of A1 given B. And the second expression is probability of A2 given B. So the correct answer is true. Does this make sense? Okay. If you feel confused at any step, please feel free to stop me because it is review for exam, so there's no point in leaving you being confused about anything. If no question, I will let you try question 6. I think this is pretty straightforward question. Please vote on Kahoot if you join there, or you can drop your answer in the chat. Okay, I see 2 people say that it is false in the chat, and one with the explanation that since 0 is an on a fair-sided die. So it is false, but that is not the reason why. It is not because 0 is not on a fair-sided die. Okay, on Kahoot, everyone say false. I hope that you will get a correct explanation. Here we have to look at what does Y represent. Y represent the number of throw until 5 appears for the first time, right? I see one student say that 0 cannot be in the range because you have to throw at least once. That is correct. You have to throw at least one time so that 5 appears, right? So it doesn't make sense for you to throw 0 times and you got a 5. That just doesn't make sense. Even if you don't know statistics, it doesn't make any sense. And another explanation that student give is 5 can appear after the 100th throw, and that is possible. That is also correct. So we don't have upper bound for Y because Y denotes the number of throws until the 5 appears for the first time. We cannot really have any restriction like what is the maximum number of throw that you throw the die. and for sure you will get 5 appears. Therefore, I also see a student give that geometric distribution x start with 1. That is also correct. So the correct range for x here, actually it is y. So the range for y should be 1, 2, 3, 4, 5, dot, 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 up to infinity. We do not have upper bound for the range of y, and the lower bound has to be 1, because you need to throw at least 1 so that you get a 5 for the first time. Therefore, 6 is false. Does this make sense? Okay, let me know if you have any question. Otherwise, I will let you start on question 7. You can vote on Kahoot or type your answer in the chat. And if you choose false, you should be able to explain why. If you choose true, I expect you to be able to show that as well. I will give you maybe 1 more minute to attempt this. Okay, so I have 3 true, 4 false, and I have someone, actually 2 people, message me true. This is a memoryless property for geometric. Yes, that is correct. This one is called memoryless property. Because if you think about it, x is a geometric random variable. So it denotes the number of trials you have to do until you get the first success. This one is saying probability of you have to do more than k plus r trials, given that you have to do more than k trials. So this is when you have to do k trials until you got the first success. And another scenario is when you have to do, this one is k plus r. And the fact that you have to do more than k plus r trial, given that it is more than k trial, you can imagine that there is some cut at k trial, and it is all failure in the first k trial. And the probability that you have to do more than k plus r is the same as probability that in the next r trial, you have failures as well. So it is just analogous in the way that you think about the experiment. So that is the first way you can think about it, or you can deal with it mathematically. We have probability that x is greater than k plus r given that x is greater than k. Here I use conditional probability formula. So conditional probability of two events is probability of the intersection divided by probability of B, like this, okay? And if we look at this one, probability that x is greater than k plus r and x is greater than k is the same as probability that x is greater than k plus r, right? Because the intersection of these two sets is just this set. Because if you think about a number line, where this one is the point k, and this one is the point k plus r, and x is greater than k is in this region. X is greater than k plus r is in this region. And the overlapping of the two regions is this one, which is x greater than k plus r. So in the numerator, I have x is greater than k plus r. And I have probability that x is greater than k here. That makes sense? Okay, and from here, I can have 1 minus probability that x is at most k plus r divided by 1 minus probability of x is at most k. That makes sense? And what is this expression? Probability that x is at most k plus r is a CDF. Yes, exactly. So I can write this as 1 minus f of k plus r and 1 minus f of k. And what is f of k plus r? What is a CDF for geometric random variable? 1 minus p to the power of k plus r. And here I have 1 minus of 1 minus is to the power of k. Does this make sense? Of course it makes sense for you because you give me the formula. How about everyone else? From this step to this, I just apply the formula for the CDF. Okay, and I will see that the 2, 1 cancel out. Is that the formula in lecture slide? I believe so. I also put it in formula sheet. Yeah. And so we are left with 1 minus p to the power of k plus r, and then 1 minus p to the power of k. And this is just 1 minus p to the power of r, right? Because I have k plus r minus k, just give me r. And I will look at probability that x is greater than r. It is 1 minus probability that x is at most r. And again, this is just the CDF. F of r is 1 minus p to the power of r. And the 2, 1 cancel. I left with 1 minus p to the power of r. So what I just show is probability of x greater than k plus r, given that x is greater than k, is equal to 1 minus p to the power of r. And probability that x is greater than r is also 1 minus p to the power of r. Therefore, this one and this one are equal to each other. Any question about this one? Does this make sense? Or is it confusing? Or you just feel lost at some step? Okay, thank you. If it makes sense, then I will let you vote for question 8. This one, just think about what is CDF and what is probability of x equal a, which is in your PMF table. What is the relation between them? I only saw 3 votes on Calwood, so please think about it. I think it is false. Why? If you think it is false, you should be able to explain why. Okay, I have 3 people vote for true and 4 people vote for false. The correct answer here is false. Okay, I see in the chat someone else put false as well. Can you explain? The correct relation is f of a equal to probability x is less than or equal to a. That is correct. This expression always holds because it is the definition for f of a. Okay. And here they say that a random variable x has a jump at the point a. Then what does this represent? What would be the probability of x equal a? If x has the jump at point a. If you think about it graphically, so you have the point a here. And before that, let's say the f value is at this level. So this is the first level. And then you have x has a jump at the point a, which means when x is at a, the function has a jump up to here, which is at the second value. Then from this graph, you can say that probability that x equal to a is the amount of jump. It is like how much did you jump from this point to this point? It is represented by probability of x equal to a. However, f of a is this point. It is not necessarily be equal to probability of x equal a. It might be when a is the smallest number in the range of x. But after that, the relation doesn't hold. And this relationship is always true. Does this make sense? Okay. Please stop me if you have any confusion. If no question, I will let you vote for question 9. I really hope we can cover all the questions. Can we cover at least question 2 on final exam? What is question 2? The set one that you asked on Discord? I think so. I see a student answer false. Why is that? So we have that. We note the color, but do not return back to the urn, which means without replacement. Since the choice after each affect each other, remember that hypergeometric distribution is when you symbol without replacement. A hypergeometric distribution is like, let's say you have m object from one group, n object from the second group, and let's say you pick out r objects from both group, and you are interested in how many objects comes from, let's say, group the first group. Then the number of objects come from the first group. Out of those are taken objects follows a hypergeometric distribution. Okay, I see someone say that it is true. It makes sense. Let's see on Kahoot. So we have equal number of people who choose true and same amount of students choose false. The answer here is true. It is because we do not return back to the urn. So it is simple without replacement. And we are interested in the number of red balls, which means the number of objects comes from one group out of the two groups that we have. Therefore, it follows hypergeometric distribution. Any question about this one? Let's give me some emoji if you think that it makes sense. Okay, thank you. So question 9 is true. It is basically just the definition for hypergeometric distribution. Let's move on to question 10. The upcoming questions is just to make sure you understand the definition for each distribution. If you don't remember, we have a negative binomial distribution. When we have x denote the number of trials until R success, then we say that x follow a negative binomial distribution with parameter R and P, where P is the probability of success in each trial and it stays the same among every trial. Okay, I see some students say that the distribution is correct, but P is not equal to 2/3. And then another student say that false because P must be 1/2. I will let other people to vote a bit more on Kahoot and then I will pick it up. Okay, so I have 3 false and 2 true. I think the student answer makes sense. The distribution is correct because we throw a fair dice until an outcome of 4 or greater appear, which means we define that when we have any outcome like 4, 5, or 6, then we divide it as success. Then probability of success would be probability that you get 4 or 5 or 6, which is just 3/6, right? Because when you throw a die, there are 6 possible outcomes, 1, 2, 3, 4, 5, 6. And 4, 5, 6 is 3 outcome, which means probability that you get 4 or 5 or 6 is 3/6, which is 1/2. And we do the experiment until we get outcome of 4 or greater for the 5th time, which means until we get the success for the 5th time. So it matches with the description for negative binomial distribution, which is number of trials until we get the 5th success. So here R should be equal to 5 and P, probability of success in each trial, has to be 1/2. So this question is false. Does this make sense? The range of this distribution would have to be 5 to infinity, right? Yes, because you want 5 success, so you have to do the experiment at least 5 times. So the range for X would be 5, 6, 7 up to infinity. Okay. If no question, I will let you vote on questions 11. Okay, so I see some students say that wrong distribution using binomial would be more accurate. And another student say that true, since we need minimum of R equal 5 times and 1/2 chance of getting even. For people on Kahoot, you can pick either true or false based on whatever I just said. It is from students' opinion, and I think one of them is true. One of them had the correct answer. Whichever make more sense to you. One student say that it should be using binomial. Okay. So on Kahoot, we have 3 true and 4 false. The correct answer is false because we need to use binomial distribution here. I know that students often get confused between the two. That's why I put this question here. But how do we know that it is binomial instead of negative binomial? Because if you look at question 10, it is we have a fixed number of success that we want to achieve, and the number of trials is what vary. We want to know how many trials until we get the 5th success. But here we throw a dice 5 times, so the number of trials is fixed, and x represents the number of times that even number appear, which means the number of success in those 5 trials. Therefore, x has to follow a binomial distribution with n equal to 5, and probability of success in each trial is 1/2 because we define success as getting even number. Probability of rolling a dice and get even outcome is probability of getting 2 or 4 or 6, which is 3/6, 1/2. Here we have the number of trials is fixed, and the number of success is what we are interested in. Does this make sense? Okay, I only saw 2 make sense. Can you give me some like thumbs up or some emoji to make sure that you are following? Okay, thank you. If no question, I will let you attempt question 12. For this, you should recall the definition for geometric distribution. Okay, I see someone say that false because it has the right distribution, but the probability should be 1/2. Yeah, just be careful about that. Like check the distribution and check the parameter as well. I'm glad that everyone chose that it is false, because here we throw a die until outcome of 4 or greater appear. So we define that when we get an outcome of 4 or greater, then it means we get success. So probability of success would be probability of getting 4 or 5 or 6, which is 3/2 or 3/6 or 1/2. And here x represent number of trials. until the first success. Therefore, X follow a geometric distribution, and P, probability of success, has to be 1/2. Does this make sense for everyone? Okay, good. If no question, please vote on Q13. I think we are almost done with the distribution thing. Only 4 more questions. Notice that is exactly the previous question. The previous question is exactly same experiment, but I said that it follows a geometric distribution. Let's check the answer. I have someone in the chat say true. On Calvo 3 say true and 4 say false. You might think that because it is the same question as Q12, and I said it is a geometric, and here you see negative binomial, so you might think it is false, but it is actually true. So I have students explain that same as geometric, when you say negative binomial have R equal to 1, that is true. We have geometric distribution with parameter P is a special case of negative binomial. It is just negative binomial when the number of success that we want is equal to 1 and probability of success in each trial is P. So here we throw a fair die until an outcome of 4 or greater appears for the first time, which means it is our success. The outcome of 4 or greater is success. And for the first time, which means until we reach the first success. So the number of success that we want is 1, and probability of success in each trial is 1/2. And it matched the description for negative binomial distribution. Any question about this one? Okay. Thank you. Let's vote on question 14. Note that when you do a Bernoulli trial, which is an experiment with exactly 2 outcomes, then the outcome of that experiment follows a Bernoulli distribution. For example, like you toss a coin and you get exactly head or tail, and let X denote like the number of head, for example, then X follows a Bernoulli distribution because X can only take the value 0 or 1. I see an explanation that it is false because X is looking at multiple Bernoulli trial. Is that true? Because here we select a ball randomly and we note the color and we just say let X denote the number of red ball that we just selected. We actually did the experiment only one. So what is the possible value for X? If X denote the number of red ball, Will the solution be posted? I will post the notes that I'm writing here. I didn't create a formal solution set for this, but I will just continue this meeting until we finish every question actually. Okay, let's see what the students say. I have 3 true and 4 false. Here we select a ball randomly, and a box contains red ball and black ball, which means either the ball that we just select is red or black. And we let X denote the number of red balls that we just selected. X is number of red balls. So X can only be 0 or 1, right? Because we only selected, like, we only did the experiment one time. Therefore, it is true because X can only be 0 or 1. And if you denote the number of red ball equal to 1 with probability P, then the probability that you get 0 red ball will be 1 minus P. So it matched the description for Bernoulli distribution. Any question? Can we treat it as hypergeometric distribution? That is a good question. Yes. Yes, you can. So because if you think about it, probability that X equal to 0 can be think of as out of N1 red ball, I pick 0 ball, and out of N2 black ball, I pick 1, divided by probability that we pick 1 ball from the box. Similarly, we have probability of X equal to 1, can be think of as from N1 red ball, I pick 1 ball, and from N2 black ball, I pick 0 ball. So yes, it actually makes sense to treat this as hypergeometric distribution as well. That's interesting. I didn't think about that when I wrote this question. Okay, if no question, I will let you vote for question 15. Feel free to just like private message to me if you have any confusion. Again, it is exactly same experiment in question 14. So think about whether we can treat this as binomial distribution. I need 1 or 2 more students to give answer, and then I will take up the solution. Okay, I see one explanation that binomial distribution with one trial is Bernoulli distribution. That is correct. So we recall that Bernoulli is special case of binomial. Bernoulli is actually binomial with number of trial equal to 1, and probability of success in each trial is P. It's good that most of students choose true. So if you see any random variable X follows a Bernoulli distribution, it means that X also follow a binomial distribution. But the reverse is not true. If X follow binomial distribution, it might not follow Bernoulli distribution. It only follow Bernoulli if the number of trial is equal to 1. And here we select a ball and we note the color. So the experiment was only done one time. Therefore, the number of trial is 1. So you can think of this as binomial distribution with n equal to 1. Does this make sense? We were able to express this as hypergeometric as well. Is this the only case at the small scale when we could use both? I haven't thought about this actually, but let's just think that it is true for this example for now. Because I don't want to tell you something in general that might be incorrect. But I think it is an interesting one when a student even brought up a hypergeometric distribution and it makes sense. So you can think of this as Bernoulli binomial and then hypergeometric. Okay, if no question, please vote on question 16. After this, you will not be bothered by this kind of question anymore. Note that here we select a ball randomly and then we return it back to the urn and then we continue the experiment. It means with replacement, sampling with replacement. I see 2 students answer true. Let's wait for one more on Kahoot and then I will take the solution up. If you think it is true, let's specify the parameter. If X follow a binomial distribution, then what is N and what is P? Okay, I see another explanation that with replacement means binomial and without replacement means hypergeometric. That is also correct. So here we have that after we randomly select a ball, we return it back, which means probability of success in each trial stay the same. And the outcome of each trial does not affect the outcome of the next trial. So you can think of this as binomial distribution. X denote the number of red balls. If we think about red balls as success, then X denotes the number of success among n trials. So we have X follow a binomial distribution. Number of trial is equal to n that we are given here. And probability of success is probability of getting red ball. And we have N1 red ball and N2 black ball. So probability of success would be N1 over N1 plus N2. Okay, I see that a student answered it as well. That's very good. Any question about this one? Okay. If not, then I will let you vote on question 17. Here you can either draw a Venn diagram or you can use the distributivity like A and B or C equal to AB or AC. You can use this property to expand this expression, or you can draw a Venn diagram. Let's wait for a few more answers and I will take this up. If you got the answer, you should be able to explain why as well. Okay, let's see the result. Most of you chose A, and that is correct. I see a student explanation about this is the student used this formula here. A intersect with the union is equal to AB union AC. So here, this chunk act as A, and each of ABC here act as the elements in the union. So I can break this down as ABCA or ABCB or A, B, C, and C complement. The first one, A and B and C and A can be reduced to ABC. A and B and C and B can be reduced to ABC. The last one, A and B and C complement is just an empty set. Why is that? Because C intersect with C complement is empty set. So there is no element that can satisfy like in A and in B and in C and also in C complement. So the last expression is evaluated to an empty set. And you have ABC or ABC, which is just ABC. And ABC union with an empty set is just ABC. So the correct answer is A. Any question about this one? You can also draw a Venn diagram and you should get exactly the same result. If no question, I will let you vote on 18. Please use the result that we just obtained for this expression so that you don't have to do everything over again. Also, if you think about it, if you have A is subset of B, then A intersect with B is just A, and A union with B is B. Because A intersect with B is the overlapping between two set, which is just a smaller circle A, and A union with B is whichever area that we have shaded, and it is a bigger circle, so it is B. So you might find that this property will be useful when you expand this. Let's wait for one more student answer, and I will take this up. Okay, I have some student vote for A, some vote for C, and also some vote for B. Let's break this down. The first part is what we obtained in question 17, which is A, B, C. And I union with A and union with B complement. And from this, I can just remove the bracket like this. And let's first think about what is ABC union with A, and then take that result, we will union with B prime. I hope you see why that ABC is subset of A, because any element that is in A and in B and in C, it has to be in A. If you draw a Venn diagram, the part ABC, it will be entirely belong inside the circle A, the part ABC. Which means I can use this rule here. ABC is subset of A, so ABC union with A is just A. So this part is just equal to A. And I have A union with B prime, which is the answer C. Does this make sense? Okay, that's good. Let's move on to question 19. So these following questions is actually the step when you do combinatorial proof, but we break it down. So for question 19, suppose that you have n people and you would want to form a committee of any size. However, the committee must have a chairperson. So in this question, we are interested in out of n people, how many ways are there that we can select a chairperson? This is very straightforward. Don't overthink it. If you have n people, how many choices are there if you want to pick a chairperson? Let's wait for one more student answer and I will take this up. Okay, so I have almost everyone chose B. That is good because you have n people, right? You have person 1, person 2, up to person n. And you need to choose one person to be a chairperson. So it can be either this one, or it can be this one, or this can be this one. there are only n options for you to choose chairperson. Or you can think of it as out of n people, we choose one to be a chairperson. So this should also be evaluated to n. Okay, let's move on to question 20. So now is after you chose a chairperson, the remaining n minus 1 people, we just need to decide who will be in the committee. How many ways are there this selection can be done? And you have to keep in mind that it can be the committee of any side. Okay, I received several answers. Most of you chose D, that is good. One student explained that each person of the remaining n minus 1 has two choices. They are either in or they are out. That is correct. If you think about it, after we chose a chairperson, then we only have n minus 1 people left, right? And each of them, they are either in the committee or they are not part of the committee. Each of them have two choices. So first you will look at this one and you decide whether they are in the committee or not. There are two possible situations. And in step 2, you look at this person and there are only two choices. They are either in the committee or not in the committee. And you do that to step n minus 1. So since they are sequential step, you use multiplication and you would have 2 times 2 times 2 n minus 1 time. Therefore, it is 2 to the power of n minus 1. Does this make sense? Okay, if no question, I will let you vote for 21. You should use the information that you have from question 19 and question 20. Let's wait for one more answer. Okay, I have everyone chose D. That is good. So we see that in order to form a committee from n people and we need one chairperson, step 1, we do whatever in question 19. We pick a chairperson. This is step 1. And step 2 is in question 20. We decide among the remaining n minus 1 people whether they will be included in the committee or not. And since they are sequential step, we multiply them together. So we would have the answer from question 19 multiply with the answer from question 20. Okay, let's look at question 22. So we still want to do the same thing, but we do it in different way. We form a committee in different way. But we still have n people. We still want a committee of any size that must have a chairperson. I see one answer is B. Why do you think it is B? The size of the committee has to include the chairperson as well, because the chairperson is part of the committee. Okay, so answer is C. Let's check on Kahoot. Majority of you chose C as well. That is correct. The reason is because the committee need a chairperson. It must have a chairperson. So you need to have at least one person that is the chairperson, right? Like that is the case where you have the least number of people in the committee. Then it has to be one. It cannot be zero. And the maximum number of people in the committee is n, because you only have n people to form the committee. Let's move on to question 23. So here, let's suppose that our committee has size k. And in order to form a committee of size k with exactly one chairperson, we will first pick the k people out of the n people, so that we have, okay, these are the k people that will be in the committee. And once you form the committee, you will pick the chairperson. So how many ways that can be done? But you just need to do whatever the question described. Do it step by step. How many ways you can do step 1, how many ways you can do step 2. And since they are sequential step, you multiply the result together. Let's wait for one more answer. Okay, so I have majority of you choose A. That is good. So the first step is that we will first pick K people to be in the committee. Out of n people, I pick K to be included in the committee. And now from the K people that I chose, out of the K people in the committee, I will choose one to be a chairperson. And it is just the same with n choose K, multiply with K. So the correct answer is A. Okay, now let's do question 24. You will need to combine the information from the previous two questions. Question 22 say that the size of the committee can be 1, 2, 3, up to n. You don't need to do any calculation, just combine the information you have from 22 and 23, and you should be able to answer for 24. Let's wait for 2 more answer from the student. Okay, so majority of you chose C. That is good. Because what it say is, given a committee of specific size K, then we have this many way to do. And what are the possible values for K? We discussed in question 22 that the size of the committee can be 1, 2, up to n. So the summation have to range from K equal to 1 up to n. And for a specific K, there is a number of ways that you can form a committee. So the correct answer should be this one. Any question about this? So the sixth question we just did, it proved that the expression here is equal to n multiplied with 2 to the power of n minus 1. Because this counts the number of ways that you can form a committee of any size that have exactly one chairperson. And this also counts the number of committee of any size with one chairperson. So they are counting the same number of objects. Therefore, they has to be equal. Let's work on question 25. I will give you a few minutes. I think for this kind of question, I always draw a tree diagram. So feel free to do so if you think it makes more sense. But it is very optional. Some people, they can just look at the question and figure out the value pretty quick. Let's wait for 1 or 2 more answer. It is a calculation question, so I don't expect everyone to get the final numeric answer. In the exam, yes, you need to give that, But here, as long as you can figure out the expression, that's good. There are two options that I don't want to see anyone to ever choose it. Okay, let's look here. I have 3 A and 1 C and then 1 A in the chat. The correct answer is A. It's good that no one choose B or D. These two options should be crossed out immediately because probability cannot be a negative number and probability cannot exceed 1. So those two, you should never choose it. It's very nonsense. So we are either between A or C. Here, the question gives us that 40% belong to life insurance. So we have the life insurance with 0.4. And then we have car is 25%, 0.25. And health is 0.35. And given that it is a life insurance holder, then the probability that they will file a claim is 0.5, which means probability that they do not file a claim is also 0.5. And here we have given that the person is a car insurance holder, then the probability that they file a claim is 0.2. So here is 0.2. And similarly, probability that a health insurance holder file a claim is 0.1. So given that they are health insurance policy holder, the probability that they file a claim is 0.1. And we are interested in the probability that the claim comes from car insurance policy holder, which means we want to calculate probability that they has car insurance and they've given that they file a claim. And here it is just probability of car intersect with claim divided by probability of claim. And what is the probability of car intersect with claim? Here we have car and here we have claim. So you just need to multiply two numbers together. And what is probability that they file a claim? We have 3 parts that they can file a claim, either through this one, or this one, or this one. So the first part is 0.4 multiplied with 0.5. 0.4 here multiplied with 0.5 here. The second part is 0.25 multiplied with 0.2. And the last part is 0.35 multiply with 0.1. And if you calculate this expression, you should get the correct answer. And in the exam, I suggest you from this step to this step, you should add one more step. That is writing the meaning of each of the number here. For example, this one multiplied with this one is probability of car is the same as saying probability of having car insurance multiply with probability of file a claim given that they has car insurance. And you should also explain for the meaning of each of the number here as well. From this step, you should go to this step and then go to the plug-in number step. Does this make sense? Okay. If no question, I will move on to 26. Please stop me if you have any question. Actually, before that, there are 3 things that you should remember for this course. The first one is finite geometric series. Next one is infinite geometric series. And the last one is Taylor series expansion of e to the power of x. So those are the 3 things that related to calculus that you will see in this course. And I'm pretty sure that you saw it in your quiz 3, quiz 4, and also in the makeup test. This also came up. So to be safe, please remember the 3 formula here. So this, when you have a geometric series. Geometric series is the ratio between each term and its previous term is the same. For example, like 1 over 2, 1 over 4, 1 over 8, 1 over 16, something like that. So here, for each term, it keep being multiplied with 1 over 2. This term is 1 multiplied with 1 over 2. This term is 1 over 2 multiplied with 1 over 2. This term is the previous term multiplied with 1 over 2, something like that. So we call this sequence is geometric sequence. And if you add them together, you have a geometric series. And here is a case where you have finite number of terms. Then this is the summation. It is saying that you take the first term, multiply with 1 minus the ratio to the power of n, where n is the number of terms. R is the ratio between each term, and A is the first term. Okay, so this is the formula for finite geometric series. And when you have infinite number of terms, then it is given by this formula, and it only holds when absolute value of the ratio is less than 1. But you don't really need to worry about that in this course because we are dealing with probability, and absolute value of probability is between 0 and 1. So it is less than 1 for sure. You can take the first term divided by 1 minus the ratio between each term. And here is the Taylor series expansion. Make sure that it starts from 0. Like the index should start from 0 and range to infinity. So those are the 3 formulas that I definitely want you to remember for the final exam. With that in mind, please attempt question 26. Remember that when you want some function to be a valid PMF, then if you sum up the function over the range of x, it should add up to 1. This is the condition for some function to be a valid probability mass function. You should use one of the 3 formulas given above. Let's wait for 2 more answers. Okay, let's check this. So all of the students who got the answer chose B. I think that is the correct answer as well. So here, in order for the function to be a valid PMF, it has to satisfy this condition. And the range of x is 1 to up to infinity, which means x can start at 1 and end at infinity. And I just copy the function that we are given, which is c multiplied with 4 to the power of x divided by 7 to the power of x. And from here, since c is a constant, it does not relate to x, so you can pull c outside the summation. We are left with c x equal 1 up to infinity of 4x divided by 7x, and this should add up to 1. And if you expand the summation out, when x equal to 1, you have 4 to the power of 1 divided by 7 to the power of 1. When x equal to 2, you have 4 to the power of 2 divided by 7 to the power of 2. Similarly, when x equal to 3, and it continues like that to infinity. So here we see that the series we have here is the same with the second series. So we can say the summation, the whole thing here, is equal to a, which is the first term, divided by 1 minus the ratio. The ratio is also 4/7 because we have 4/7 squared divided by 4/7 is 4/7. Similarly, the ratio between these two terms is also 4/7. So we have 4/7 divided by 1 minus 4/7 is 3/7, which is 4/3. So C should be 3/4. So the student asked, it doesn't matter that the sum start at 1. So the thing is, if you use this summation expression, then yes, it does matter. But if you just expand it out like this, then no. So that's why I always expand out, so I don't have to deal with the index, because for different index, you might need to adjust what is inside here, what is the term inside here. It will be different. If you have it start with 1, you might need to adjust it by some variable to initialize it to start at 0. Or you will need to eventually minus the first term. Does it make sense? Like this whole thing, you can write it as summation of 4/7 r to the power of k, where k start from 0 to infinity. And this is the same as if you say r to the power of k, k start with 1 to infinity. They are actually the same series. But if you have something like this, you will need to change it to this form so that you can use the formula here. So that's why I don't normally deal with the summation one, because I don't remember the index. If you just expand it out like this, you can always take the first term divided by 1 minus the ratio, and it is always true. If no question, I will let you attempt this one is 27. Make sure that your calculation is correct. Let's wait for one more answer. Okay, I have most of you choose D. That is correct. So in order for this function to be a valid PMF, then the summation over the range of x, which is starting at 0 and end at infinity, it has to add up to 1. So here I have the range of x is from 0 up to infinity, and I copy down the function that we are given. And again, c is a constant, so I can pull it outside the summation. And this summation here, if you remember it, it was actually the third formula. It is the Taylor series expansion of e to the power of x. So here it is e to the power of 4, because 4 is in the position of x here, and the x that we are dealing with is in the position of n. So here would be e to the power of 4, and therefore c is 1 over e to the power of 4. Any question? If not, then please attempt question 28. You can just answer what is the probability that at least 2 of the machines selected are defective. We will construct a PMF together. Let's wait for one more answer. Okay, so we are 50-50 between C and D, and then in the chat, people give me D. The correct answer here is D. Let's first construct a probability mass function. So X denote, what does X denote? X denote the number of defective machines. And we select 6 machines at random to check whether they have error or not, which means the number of defective machines minimum is 0, which is none of the machine is defective, and the maximum number of defective machine is 6 because the engineer select 6 machines. So at most, in the worst case, we have all of the 6 machines are defective. So we construct a table. X can take on value 0, 1 up to 6. And in the second row, we want to fill in what is probability that a random variable X is equal to a specific value X. Remember that the uppercase denote a random variable and the lowercase denote a specific value. So in the first one, I would want to fill in what is probability that X equal to 0, which means what is the probability that we have 0 defective item. In order to do that, out of 8 defective, we choose 0. Out of 42 non-defective, we choose 6 because we want to sample 6 machines, right? And divided by total number of ways that we can select 6 machines, we have 50 machines in total, and we want to select 6 machines out of that. So this is the probability that X equal to 0, and we do the same for X equal to 1, which means we want 1 defective item. So out of 8 defective, I choose 1. Out of 42 non-defective, I choose 5. And I do that for the rest. And the table that we just created is a PMF. Why do we divide by that amount? Because it is the total number of ways to select 6 items. This one is total number of ways to select 6 items. We have 60 machines in total. So the number of ways that we can randomly sample 6 machines is out of 50 machines, we choose 6. And the numerator is the number of ways that we have 0 defective machine. So we have probability that we have 0 defective. It's just the number of ways to select 0 defective. And we have 6 machines in total. We select 6 machines in total divided by number of ways to select 6 machines. Does it make sense? Yes, okay. And here the question asks for probability that at least 2 of the machine are defective, which means the number of defective machine is at least 2. And it is 1 minus probability of X less than 2. And keep in mind that this is discrete random variable. So you look at the table, which value of X is less than 2? Only 0 and 1. So we subtract the probability X equal to 0 and probability of X equal to 1. And that is what part D gives us. Does this make sense? Okay, thank you. If no question, let's attempt 29. We are almost there. Let's wait for 2 more answers and I will pick it up. You can either construct a probability mass function and compare it with the distribution that you have in mind to see if they are the same or not. But this should make intuitive sense for you why x1 plus x2 give you such distribution. Okay, so among all the people that voted, you got the correct answer, which is D. Let's see why is that. X1 follow a Bernoulli distribution with parameter P. So you can think of X1 as a Bernoulli trial, like you have a Bernoulli trial, you have exactly one Bernoulli trial, and this is either success or failure, and the number of success is denoted by X1. X1 is number of success in this one trial. And also you have another trial and you have X2 denote the number of success in this trial. Then if you take number of success here plus number of success here, it gives you the total number of success among these two trials, right? And the number of success in two independent Bernoulli trial is exactly what the description for binomial random variable represent. And probability of success in this trial is P. Probability of success in this trial is P. So in all two trials, probability of success stay the same as P. So this choice makes sense. And if you want to construct a probability mass function for it, let's first look at what is the possible value of x1. Range of x1 is 0 or 1 because x1 is Bernoulli. Range of x2 is also 0 or 1 because x2 is also Bernoulli, which means when you take x1 plus x2, let's denote it by y equal x1 plus x2, then the range of y is 0, 1, or 2, right? Minimum, it is 0 because it cannot be negative. And 2 because at maximum, x1 is 1 and x2 is 1, then the sum will be at most 2. So we want to create a PMF table for this. So y can take on value 0, 1, or 2. Here I want to fill in the probability that y equal to 0. When is y equal to 0? So probability y equal to 0 is when x1 equal to 0 and x2 equal to 0. And since they are independent random variable, we have probability of x1 equal to 0 multiply with probability that x2 equal to 0. And now I just fill in probability that a Bernoulli random variable take on value 0, which is 1 minus p and 1 minus p. Because here is just probability that a Bernoulli random variable take on value 0, similarly to this. And when y equal to 1, let's say when y equal to 1, then it means 1 of x1 and x2 be 1, and the remaining random variable is equal to 0. So it would just be out of 2 random variable, I choose 1 to take on value 1, and the remaining will take on value 0. And when it take on value 1, then probability that a Bernoulli random variable take a value 1 is p, multiply with probability that a Bernoulli random variable take on value 0. Does this one make sense? So here out of x1 and x2, I choose one of them to take on value 1. Let's say x1 take on value 1. So x2 will take on value 0. And I multiply with probability that x1 equal to 1, which is p, because x1 is Bernoulli, and multiply with probability that x2 equal to 0, which is 1 minus p, because it is the probability of failure for a Bernoulli random variable. And when y equal to 2, it means both x1 and x2 has to be 1, which is p times p. And you will see that this PMF table is exactly the same with a binomial random variable with n equal to 2 and probability of success in each trial equal to p. Any question about this one? If not, then I will let you vote on question 30. Let me know if you have any question. We only have 36 questions, so almost there. I think we did this one in tutorial. You should think about what does x1 and x2 represent. So x1 follows a binomial distribution with parameter n1 and p, which means x1 denotes the number of success in these n1 trial. So you have n1 trials, probability of success in each trial is equal to p. And you have some amount of success in here. And we denote this number of success by a variable called x1. And you have another n2 trials. And you denote the number of success that you have in this n2 trial by x2. Then think about what does it mean by taking x1 plus x2. Let's wait for one more answer. Okay, I have most of you chose C. That is good. It is C. Again, you have N1 trial and the number of success in those N1 trial. How many success do you have in here is denoted by X1. And you have another N2 trials. How many success you have in here is denoted by X2. If you take the number of success here plus the number of success here, it tells you the total number of success in the whole trials that you have here. And how many trials that you have here? You have N1 plus N2, right? You have N1 plus N2 trials in total. And the probability of success in each trial is also P. Therefore, the total number of success in N1 plus N2 trial follows a binomial distribution. It is exactly the description for binomial distribution. Does this make sense? Let me know if you have any question. You can also try to derive the PMF by yourself to confirm that. If no question, I will let you vote on 31. You can message me privately if you have any question. Again, this was also covered in the tutorial. X1 follows a geometric distribution. So X1 denotes the number of trials until you get the first success. So here you have X1 trials. And then similarly, here you have X2 trials. What does it mean by taking this amount of trial plus this amount of trial? Like, think about the meaning of it. Let's wait for one more answer. Okay, so most of you chose B. That is good. It should be B. So let's think about the meaning. X1 follows geometric distribution, and by definition, X1 should be the number of trials until the first success here. And similarly, X2 is also number of trials until this success here, the first success here. Before that, it is all failure. And negative binomial is the number of trials until you get the R of success. If you take X1 here plus X2 here, it gives you the total number of trials until you reach the second success, right? Because here is till the first success, and here is a bunch of failure until this is the second success in the sequence. So X1 plus X2 exactly match the description for negative binomial with the number of successes 2 and probability of success in each trial is P. Does this make sense? One student asked me, do you think being able to solve all these problems is enough for the exam? It depends on what you mean by enough. I cannot guarantee you to get like 100 for sure. But I think if you can solve everything correctly, you are in pretty good shape. I just advise you to do more problems related to PMF and CDF, like construct a PMF table and from there draw a CDF graph and like define a CDF function. And also from CDF, being able to answer the probability x equal to specific point or x is less than or greater than some point. Like that is a question that I forgot to include it in this review. But other than that, I think you are in pretty good shape. Okay. If no question regarding to this, I will let you attempt question 32. Here, I suggest you to calculate, you use a formula that variance of x equal to expected value of x minus mean squared. This formula will be less computation than using the second formula. So you might need to see what is the mean. Mean is expected value. You will need to first find this and then find this one based on the formula. Expected value for a function of x is equal to summation of the function of x multiplied with the PMF. So you first figure out this and then use this formula to solve for this one. And it will give you the variance for x. Let's wait for one more answer. Okay, let's see what you got. Everyone that voted chose A. That is correct. I hope you didn't just get the answer in the chat. So first, let's calculate expected value for x. It is given by the formula. Take the actual value of x and multiply with the corresponding probability. So what we are doing is you will go through each column in the PMF table, take the value of X, multiply with the probability correspond to it. So I have 98 multiply with 1/5, and then plus 99 multiply with 1/5, and then 100 multiply with 1/5, and I do the same for 101 and 102. And the expected value I get is 100. So here I would find the expected value of X minus 100 squared. And I will use this formula here. In order to do that, I need to create a row for X minus 100 squared. So when X equal to 98, 98 minus 100 is 2, and you square it, you got 4. 99 minus 100 is -1 to the power of 2 is 1. Similarly, I fill in for the other 3 columns. And so the expected value of X minus mean square is, again, I go through each of the column. I take the value for X minus 100 squared, multiply with the corresponding probability. So I have 4 multiply with 1/5. And I move to the next column. I take 1 multiply with probability, which is also 1/5. And I do that for every column. And it should give me 2. Any question here? When you want to calculate expected value of a function of X, just create a row that represents that function and calculate the value of that function for each value of X. And then you will just multiply with probability and then adding them together. If no question, I will let you vote on 33. Now you can use question 32 to answer 33 pretty fast. Let's wait for one more answer. Think about what is the relationship between expected value of X squared and variance of X. Okay, so I got everyone to vote for C. That is correct. We know that variance of X is equal to expected value of X squared minus expected value of X and everything squared. Therefore, expected value of x squared can be rewritten as variance of x plus expected value of x and everything squared. Variance of x was calculated as 2, and expected value of x I calculated as 100, and I squared it, so I got 10,000. And I add them together, I have 10,002. I hope that this makes sense. Let's think about question 34. You should use linearity of expectation. Okay, so whoever voted, we also got D. And it is the correct answer. Let's try to break this down. By linearity of expectation, I can write this as expected value of 2n cubed plus expected value of 3x squared. And you can move the constant outside. And in the previous question, we calculated expected value of x squared, which is 10,002. So we know this value, and we only interested in calculating this one, which means we need to calculate expected value of n cubed. So let's create a row for n cubed. So we have n cubed here. Again, it is just calculating expected value for a function of random variable. So you create a new row for that function and calculate the value at each point of n. 0 cube is 0, 1 cube is 1, 2 cube is 8. So now expected value of n cube, you will go through each column, take n cube, multiply with corresponding probability. So I have 0 multiplied with 1 over 3, 1 multiplied with 1 over 3, and 2 cube is 8 multiplied with 1 over 3. And this one should give us, the first term is 0, and then I have 9 divided by 3, which is 3. So I have 2 times 3, and then 3 times 10,002, and this gives us with 30,012. Any question about this one? I didn't write solution before this session, so I will just post this one, the one I'm writing. If not, then let's move on to question 35. We only have 2 questions left. You're welcome. I was thinking about typing up a formal solution, but I had final exam as well, so I didn't have time for that. And I think like I will post this recording anyways, and then post the note that I write. So I think it should be enough. Okay, so I got, most of you got C. Actually, everyone who answered got C. And it is a correct answer. So we have a random group of 40 people, and we want the probability that at least 2 of the people share the same birthday, which means it is 1 minus probability that no one share birthday. Which means that if you look at the first person, how many choice can they have for their birthday? That is 365. And the second person need to have birthday different from the first person. So it is 364. The third person birthday has to be different from the first 2, which is 363. And like that up to the 40th person. So they have 326 choice for birthday, and divided by all the possible choice for birthday, which is like everyone have 365 choice for their birthday if there is no restriction. So this one would give you probability that there are at least 2 people who share the same birthday. I will let you vote on 36. Let me know if you have question about whatever we just covered. Okay, let's check the answer. So most of you got B. B is the correct answer. Why is that? We want to calculate probability that someone has the same birthday as you, which means you have your fixed birthday, right? And we want to take 1 minus the probability that no one has same birthday as you. There is a student sent me their explanation. Each of the 40 people just need to have a different birthday from me, not amongst each other. They just need to choose any different day from the 365 days each. That makes sense. So imagine that your birthday is fixed and you want no one to have same birthday as you. So they can pick any day out of the remaining 364 days, as long as it is not the same with your birthday. So they have 364 days for the first person, 364 days for the second person, and similarly for the 40th person. And divided by the number of ways that they can have their birthday if there is no restriction. And this one is the expression in part B. And these two questions, they actually have application in cryptography if you are ever interested, because most of the people think that those two questions need to have the same answer, but it turned out that they have very different answer. Question 35, it is pretty big probability, but for 36, it is a very small probability. Is there any other question for today review? I definitely want you to look again at tutorial 7 and tutorial 8, because I think I didn't cover enough for the CDF part. Will you upload the note on Quarkus? Yes, I will upload it right after we finish this one. I will also try to post the recording as soon as Zoom is available, because I need Zoom to convert the recording into video, and then I will upload it. Do we have multiple choice question in the final? I'm not sure about the upcoming final, but the last year final, yes, there was multiple choice. ITA for Masu last semester, there was also multiple choice. So yeah, just be prepared for it. And I mean, either multiple choice or not, you should know the concept well in order to solve it. If no question, then it's the end of the review session today.